Happy morning to one and all present here. On behalf of Computer Science and Computer Application Department, I take immense pleasure in welcoming you all for this virtual power seminar on Happy morning to one and all present here. On behalf of Computer Science and Computer Application Department, I take immense pleasure in welcoming you all for this virtual power seminar. Happy morning to one and all present here. Happy morning to one and all present here. On behalf of Computer Science and Computer Application Department, I take immense pleasure in welcoming you all for this virtual power seminar on data science. I deem it a privilege to welcome our Honorable Chairman, Thiru M.A.K. Balakrishnan, respected directors, our Dean Dr. R. Revati ma'am, and our dynamic principal, Dr. R. Geeta Rani ma'am. Welcome ma'am. Let's welcome our resource person, Mr. Dilip Muralidharan, Senior Technical Instructor at Splunk, Chennai. Mr. Dilip Muralidharan is a seasoned education consultant with 15 years of experience in IT industry, 10 years of experience in consulting, designing, customizing, and delivering technical training on enterprise IT software platforms. He has proven delivery methods with extensive travel Asia, Greater Chennai, North America, and India. Welcome you, sir. At the outset, I welcome our ICT Academy coordinator, Mr. Naveen, and his team for the extraordinary support in all our endeavors. Last but not least, I welcome all the participants of this power seminar and request you to utilize this wonderful opportunity to enhance your knowledge. Once again, welcome you all. Now I request our resource person, Mr. Dilip Muralidharan sir, to carry over the session. Thank you one and all.
Thank you, Dr. Gayatri. Good afternoon, everyone. Hopefully, I am audible. If someone can confirm over chat, that would be great.
Mr. Dilip Muralidharan sir, to carry over the session. Thank you one and all.
I'd appreciate if the speaker can be muted on the other end. I'm not sure. I'm not able to hear myself. Okay, all right. So I guess the audio issue is now taken care of. If someone can confirm that I am audible, I'll appreciate it. Let me quickly share my screen here. All right. So hopefully the screen that I am sharing is visible and right. So welcome everyone to the data science seminar. So what we are going to do is we're going to talk about data science. We're going to talk about data science from the perspective of where data science comes from and what exactly are its applications, what are the current trends, and also what are the future possibilities when it comes to data science. So in the interest of saving time, what I'm going to do is I'm going to set a quick timer here for 45 minutes. I'm going to take 45 minutes of your time to discuss data science with you so that, I can have an additional 10 or 15 minutes for questions and answers at the end of the lecture. So let's go ahead and get started here. Here's a quick synopsis of where I come from. I basically come from an IT product background. What I do is I have worked in product companies for the past 18 and a half years, close to 19 years now. I currently work for a company called Splunk, and I am a senior staff instructor with Splunk. So I mostly do education and consulting work day in and day out. So before getting started with the actual event, what I would like to do is I would like to quickly take the time to thank the management, the teaching, and the non-teaching staff of the college. I would also like to take the time to thank ICT Academy for helping put together this event. And of course, most importantly, I'd like to take the time to thank all the participants who've pulled away from their regular schedule to attend this particular session. So what I've done here is I've split this session into 3 parts. So the first thing that I'm going to do is I am going to talk about data science. What exactly is data science? And the second part, we're going to talk about what exactly are the applications for data science? What exactly is data science used for? And then finally, what I would like to do is I'd like to show you a demo. I'd like to demonstrate using a simple setup that I have here as to how data science works. All right. So that's the agenda for today. So let's go ahead and let's talk about data science. What exactly here is data science? Well, data science is, it's a very broad terminology that is used to refer to a collective set of technologies that address a specific use case. So if I go to, let's say, for example, I go to Wikipedia and I look at the definition for data science on Wikipedia. So what exactly does Wikipedia say about data science? Well, Wikipedia says that data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data, right? So, and then it says we apply that knowledge and actionable insights from the data across a broad range of applications. So seems to be a bit of a complex definition right there, right? So let's break it down and let's try and understand what data science is here. So in order for me to explain this to you in the most easiest manner, I'm going to take you back in time about 14 years, and I'm going to start with my own personal experience, and I'm going to take you through the process of data analytics as such, so that you get to understand the entire field of data science with a practical example. So way back in 2004, I believe, right? 2004 to 2008. I used to work for a company called Computer Associates. It's now called CA, but at that point in time, it used to be called Computer Associates. So at Computer Associates, my role was that of a support engineer. I was a support engineer, and what I did was I went ahead and I worked for the storage and recovery management portion of the business. So with the storage and the recovery management portion of the business, specifically worked on backup and backup software and high availability software, right? That's what I used to support for customers. So our customers were usually small scale enterprises or small and medium businesses. Those were our primary target segment. Now, what happened with our customers is that sometimes some of them will have trouble dealing with problems in their backup. Their backups would fail. They would not run as expected. Okay, fair enough. So that's something that we can expect in pretty much every environment, right? There's no trouble-free environment out there. So most of these problems can be resolved by some basic troubleshooting, which is what we used to do. But some of the problems cannot be resolved with basic troubleshooting. Some of the problems will require a higher level of review. Now, when I say these problems will require a higher level of review, what I mean by that is we will typically run into problems where we'll have trouble along the lines of, let's say, we would find some complex problem requiring some research. And in order for us to research these problems, we used to procure logs from customers. Now, one of the things about logs is that if you procure, a few log files from a customer, that in itself is a sufficient level of complexity. But if you procure a lot of different logs from customers, then what's going to happen is that that log information is going to become quite complex. It's not only going to become quite complex, but it's going to become voluminous in nature. Let me give you an example. One of the things that is most sought out when it comes to backups is your email servers, your Exchange servers. So Microsoft Exchange was something that we used to back up with our backup software. We used to have a backup agent that used to run on the Microsoft Exchange machine. Now, what happens is that when we go ahead and receive debug logs or trace logs from customers for the Exchange server, our customers were usually requested to upload their log files in a sort of a FTP drive, right? And once our customers, uploaded the log files to the FTP folders, we used to go download these log files from the said FTP folders. Now, most of the log files that the customers used to upload were, compressed log files. So they used to come in WinZip or WinRAR, something like that, and we used to go ahead and download them and uncompress them. The problem with this is that when you uncompress a 25 megabyte log file, it suddenly becomes a 7 gigabyte log file when it's uncompressed. So opening this log file in a text editor in itself could be a problem, because opening this log file could actually take time. It could take quite a bit of time to open up. So we used to do very, silly things like, for example, I used to open up all of my big log files when I used to go for lunch or dinner, and I'll go and get this information from the log environment, and I'll go and parse these log files. In the meanwhile, I'll go get dinner, which is like a 25-minute break. So we did not, have a way to work around this particular problem at that point in time. The other issue here was that the logs were so complex, it's very difficult to read these log files. So the difficulty of reading these log files was another problem. So what we used to do was we used to write our own scripts. We used to write our own Java programs or Java applets. We used to write our own C code or Unix shell scripts or even Python scripts. And these scripts used to analyze our data. Now, why am I narrating all of this to you? Stuff that happened almost 18 years ago. Well, we did not have a name for that problem that we had at that point in time. But today we understand that as big data. That is how we understand this, right? Big data was the problem that we were trying to address and resolve at that point in time, and big data was the problem that we weren't able to address and resolve at that point in time. So eventually, what happened was that, you know, um, we worked around that problem by getting some log analysis tools that we built ourselves. And as and when we started parsing these log files and we started, to get some meaningful insight out of these logs, right? So what's problematic is that um, it's difficult for us to understand patterns of behaviors that that were going around. So we used to write some basic mathematics into our scripts, and we used to analyze these log files. And we used to do some basic multiplication, regression analysis, right? Reminder divisions and whatnot, quadrile functions, all of these things. So eventually, what happened was, over the period of time, what happened is that these math algorithms that we used to run on these log files were essentially nothing but these were, machine. These came about to be called as machine learning. So machine learning is a concept where you take either a logic-based approach or a pattern-based approach, and you analyze the data with the help of simple mathematics or statistics. So this continued for some time, and then what happened was that computer scientists came up with the idea, what if the data could think for itself? What if the data could independently interact with itself? Well, that's what we essentially did. What we did was that we started building something called as neural networks. Now, everybody knows what a neural network is already, right? A neural network is something that we frequently refer to when we talk about the human brain or when we talk about the animal brain. The neural network, I mean, take the human brain or take any animal brain, right? Essentially, what these are is that they are all, just countless numbers, millions, or if not billions of neurons that are firing against each other, right? And these neurons take electrical impulses as data and they communicate with each other, right? So these neural networks are essentially going to, go ahead and these neural networks are going to form the basis of human brain communication. Likewise, in computing as well, neural networks are where we build, a neuron, which is essentially nothing but a unit of work based on a task, based on a piece of data, right? So these, neurons will fire and they will understand each other in the context of each other. Now, we also have data models. Data models are essentially nothing but organized data sets that are in a hierarchy that are arranged to build this particular to build this particular data model for us to understand our data better. One of the things that comes out of this is predictive analytics, right? Data science, specifically with the use of machine learning, one of the outcomes is artificial intelligence, and the application use case for artificial intelligence is predictive analysis. There are a number of ways in which predictive analysis is being used today. Predictive analysis is not something new. We've been using predictive analytics for at least 6 or 7 decades. I mean, man set foot on the moon because of predictive analytics, right? You get weather forecasts because of predictive analytics. You get stock market forecasts because of predictive analytics. I mean, the recent mission to Mars that failed, or the Chandrayaan mission, which was successful from ISRO, all of these are possible because we're using machine learning, we're using the tools of data science to involve the trajectory, to build a trajectory as to how, a particular spacecraft is going to act out in deep space. So these are all the things that can be done with the help of predictive analytics. So that in short is the field of data science. So that brings us to the next obvious question, which is the use case for data science. What exactly are the applications for data science? What is data science used for? Well, there are so many applications, there are so many use cases for data science. I can keep talking about use cases for data science for weeks together. But what would be easy for me to do would be to just talk about data science from a use case point of view, specifically from a particular set of use cases, right? So the use cases are going to be the most frequently used use case. So that's what we are going to discuss. So what are these use cases? Well, the first use case that I want to talk about is transaction monitoring. What exactly is transaction monitoring? Well, think about this for a moment, right? You go to a website like Amazon, or you go to a website like Flipkart or Myntra, whatever, any generic e-commerce website. Now, this e-commerce website, what it does is uh, all that it does is it goes ahead and it allows customers to buy products or services online over the internet. Now, that brings us to the very obvious question, right? What if a sale is going to fail? What if I enter my credit card number and I pay the money was taken from my credit card account, right? But the sale did not complete, the transaction failed. What happens then? Well, that's where transaction monitoring comes into the picture. We use a lot of different techniques available in data science to monitor all of our transactions. You see, any transaction that involves some kind of currency is going to have two parts associated with it. One is the actual order ID. The other one is the transaction ID or the payment ID. The order ID is going to contain information about the orders. The order ID will contain information about what kind of products have been purchased, how many of these products have been purchased, what exactly are the discounts that were applied, what is the delivery address, who's the contact name, and the information about the person who is making this purchase. The next thing is, your payment ID or your transaction ID. Your transaction ID will contain information about the money that was paid for the order. It'll contain the credit card number or the bank account number or the debit card number or a prepaid wallet number. Something like that will be available in order for us to get access to that particular entity. So, when a transaction is going to fail, what you will have is you might have a successful payment ID, but you might not have a successful order ID. What that means is that money was taken from the bank account or the credit card account of the customer, the product was not issued. So automatically, what we will do is we will go ahead and we will just refund that particular order proactively. Now, that's the reason why, when you call an Amazon customer support number and you talk to the customer support officer, that person is readily able to tell you, hey, don't worry, your money will be refunded to you in like 3 days or 7 days or 10 days or 14 days, something like that. They're able to give you a timeline when your money will come back into your account, right? So again, that's transaction monitoring. Predictive analysis is another use case. Weather forecasting, today, real-time weather forecasting is done with the help of predictive analytics. We analyze what exactly is the trajectory of a particular weather pattern using historical data, and then we are able to predict what's going to happen to that particular weather pattern, right, immediately in the near future. Media and entertainment is another use case. Today media consumption has come to your cell phones. You can actually go and you can make your phone do all the entertainment work for you. Case in point, all of your OTT apps like your Netflix, Hotstar, and things like Spotify, Ghana. These are all OTT apps that deliver video or audio content to you day in and day out. Now, if you actually subscribe to the premium service of any of these platforms, you'll actually understand that um, there is an algorithm that is working for these apps, which largely accurately predicts what kind of music you are going to like. So, with that being the case, right, what we are going to do is we are going to go ahead and we are going to think about, how do these apps work? How do they leverage data science? The way they leverage data science is that they actually also make use of predictive analytics to a large extent, right? And they look at user behavior. So there's a module in there called user behavior analytics. And based on the past behavior of the user, they predict what kind of content the user might consume in the current trend. Healthcare and diagnosis, that's another excellent use case where data science is playing a huge role. Gone are the days when if you run your lab test results, it'll take a few days for your results to come back. I mean, recently, 2 weeks ago, I had to go to an orthopedic consultant to have a regular health checkup. And, I was ordered a plethora of blood tests. I was ordered blood tests to the tune of some 70 different blood tests, and I had to spend quite a bit of money on those tests. Now, those blood test results actually came back within 2 hours. The reason why the blood test results came back in 2 hours is simply because, blood testing is now a computerized agenda. We go ahead and we take the blood sample into a computerized analysis machine, and that machine automatically tells us what exactly is, the numbers, the figures with regards to what is the status of your blood. Same thing with the MRI and CT equipment that we have today as well. I had to go in for an MRI, I had to go in for a CT as well. And the cool thing about my MRI and CT was that not only was the MRI and CT very quick and efficient, but a soft copy of the MRI and CT files were actually made available to my doctor, right? That's a very interesting thing. Why is that an interesting thing? Because it's a computerized setup, and automatically the MRI captures the necessary images, and the CT also captures the necessary images for us to work with. The other important use case in the healthcare industry is that we actually do a lot of things today with the help of data science. So case in point, think about cancer treatment. In cancer treatment, one of the most widely used treatments for cancer is radiation therapy. And one of the biggest shortcomings of radiation therapy is that it not only affects your cancerous tissue, but it also ends up affecting your healthy tissue that is not cancerous in nature. Now, why is that important? It's important because you cannot have healthy tissue be compromised as well, because the patient is already weak, right? They're frail. So today what we are doing is we're injecting patients with a special kind of dye, a pharmaceutical dye. And that dye only sticks to cancer cells or cancer tissue. And once we use radiation on the cancer tissue, on the area where there is cancer, what happens is that immediately, we will notice that will notice that um, uh, the radiation equipment is programmed using data science algorithms to tune itself to focus only on the tissue that is marked by a dye, and it ignores the tissue that is the healthy tissue that is not marked by a dye alone. So the quality of healthcare that is provided via radiation to patients drastically improved. So the survival rates for cancer patients also improved. IT security is another fantastic use case. IT security is essentially where we go ahead and we no longer have to manually disinfect, clean, and quarantine our machines infected with malware. What we do is we go ahead and we just set the automatic updates on our machines to patch all vulnerabilities, and our malware scanning software as well is able to quarantine our machines and automatically raise a support ticket with the IT help desk if we get infected. So these are some of the most prevalent use cases for data science, right? So I don't like to go on and on and on about use cases. I would like to mention that data science is all based on math and specifically statistics. So there are a lot of algorithms that are in play when we discuss data science. Now, I cannot show you a lot of algorithms for lack of time and for lack of resources. I have 4 different algorithms that are available with me in my environment today that I can demo, that I can show how they work. So I'm going to show you, right? For lack of time, I've got 17 minutes. I'll show you a predictive analytics example using Splunk ITSI. And if I have time, I'll also show you some sales analytics for e-commerce data as well, right? So what I will do is I'll just go to my machine here, and I'm going to go into ITSI. Now, ITSI is a Splunk product, and ITSI essentially what it does is it is an IT service management product, right? So this IT service management product basically tells you what exactly is the health of all of your IT infrastructure. Now, right now, I'm monitoring 3 different services: online sales, storefront web farm, and support web farm. I'm only interested in online sales, so let me pick and choose the online sales service here, right? Now, this online sales service, it has 3 KPIs at the bottom. You can clearly see I've got purchases, volume, and views. Purchases are nothing but the actual number of times, number of products a customer has purchased from your online store. Views are nothing but the number of times a customer has viewed a product. And volume is nothing but the actual volume of the traffic, right? So this is what happens. This is how the performance of the online sales service is measured. And the performance is measured between 0 and 100%, right? Now, the problem here is that right now, the online sales service is running at 82.1% efficiency. Now, what I want to do is I want to use machine learning, and I want to understand what's going to be the future, the near future. I want to know how this service is going to function in the next, let's say, 30 minutes. So in order for me to do that, I need to train this data using algorithms. So how do I train this data using algorithms? Well, the easiest way for me to train this data is to actually go and configure this service. So I'm going to go into my configuration here to configure this service. And in my service configuration, what I want to run is predictive analytics. So I'll edit this service here, and I will go to the predictive analytics module. Here, I'll use the last 14 days, choose the regression analysis algorithms. And I'm going to train these on linear regression. I'll hit the train button. When I hit the train button, you can clearly see that the split for training and test is 70-30. What does that mean? Well, we are going to use 70% of the data to train the algorithm and 30% of the data to test the algorithm. So right now it's building a data model. You can see that it's spinning. It says creating model right here. It's building a data model for this particular piece of data. So that's not a problem. What I will try and do is I'll just wait for this to complete. I have to be patient and I have to wait. It's going to take a few minutes for this to complete because it's the volume of the data is pretty huge in nature, which means it's going to take some time for this algorithm to run. We have time. We still have 13 more minutes to go. So I'll train the next algorithm, which is random forester train. I'm using the same 70-30 split. I'm using 70% of the data to train the data and then 30% of the data to test the data. So that's what the next algorithm is about. It's the random forest regressor algorithm. So let's wait for this to complete. It's taking time for it to complete. So the third algorithm that I want to train is the gradient boosting regressor. I'll train that algorithm as well. So this will also take some time to complete. It'll take some time, but it'll eventually complete for sure. Okay, so the next thing that I want to investigate is the classification algorithms. Logistic regression, this is most probably not going to run because the data won't fit the algorithm. Yeah, you see, every algorithm needs to fit the data. There are specific algorithms that fit specific types of data. This one, unfortunately, I don't think it will fit the data. There you see, that's fine. I'll click the save button to save all the training for the algorithm. All right. Now notice something interesting here. Splunk is able to automatically tell me which algorithm is the best by giving the recommendation for the algorithm. And if you notice, there are some interesting statistical values. These are all, this is all data science being implemented via machine learning. I get the R square value. The R square value is nothing but the measure of how the model approximates to the real world data. RMSE's root mean squared error, that's the actual value and the difference between the actual prediction. So we've got actual versus predicted health score, and then we've got the residual error. So we've got predicted average case service health score 72, predicted worst case health score 60. So it's going to be between 72 and 60. So let me go to the Predictive Analytics dashboard here. And what I will do is I will select the online sales service. And because it's the online sales service, I have my trained models. I'll choose the gradient boosting regressor. Now what happens is this model is going to, this data model is going to be run against the actual data. And now it says it's 58.97%. I can even click on this cause analysis button to see all the different causes here and see what exactly is happening with the environment. So I've got the predicted top 5 contributing KPIs. I've got the KPI predictions here, all of that. All right, so these are all the predicted top 5 contributing KPIs. You can see the prediction for the KPIs as well here. What's going to be the status of these KPIs? This is how predictive analytics works. This is all basically just machine learning that implements some kind of predictive analytics. That's what's happening here, right? So what are the future trends for data science? Well, there's plenty of possibilities, but I would like to discuss an interesting use case with you. The use case is Neuralink. Neuralink is essentially a company um, that's owned by Elon Musk. Elon Musk is the same person who owns the Tesla electric car company, you might be aware. So Neuralink is nothing but it's a chip that is implanted in the cerebral cortex of the brain. There are plenty of things you can do with Neuralink. One of the important functions here is that it can stimulate dead portions of the brain. It can also reanimate activity to assist people with disabilities. So it's very useful when it comes to palliative care, right? So there's plenty of videos available on the internet about Neuralink. You should definitely go look up the internet about Neuralink. So in fact, one of the best places to go look up Neuralink would be to actually go to YouTube. And in YouTube, if I go to Neuralink, Elon Musk. So there are plenty of interviews about Neuralink, right? So, this interview, Elon Musk's interview about, a Neuralink demonstration is fantastic. So I think you should definitely, watch this interview. So I'm going to paste that link here in the chat window for you all to, open and bookmark. But there's plenty of examples for Neuralink like this. So if you want to if you want to learn more about Neuralink, you should definitely, go to look at the YouTube videos. There's even one in Tamil that's available. So I'm going to put that link as well. So in short, right, that essentially is all that there is to talk about data science, right? So I've taken lesser time than I promised that I would take. I've ended about 6.5 minutes early today. So I'm going to open up the session for questions. So if you have a question, please go ahead and ask questions. I'll take questions for the next 10, 15 minutes, even 20 minutes. And when we no longer have questions, we will wrap up today's session and call it a day. Any questions? Let me stop the screen so that I can see any questions on chat, if there are. Any questions? If we don't have any questions, then we can wrap up the session for the day.
Application department. I thank you very much for your wonderful session. Thanks a lot. Thank you, sir.
All right, thank you. Have a nice day. Goodbye.